Good morning, students. This is Viswanath, Chemistry faculty for IIT and NEET exams. Last class we completed some of the numericals. Now see the next one. An aqueous solution of an aniline of concentration 0.24 molar is prepared. What concentration of sodium hydroxide is needed in this solution so that anilinium ion concentration remains at 1 into 10 power minus 8 molar? Ka for anilinium ion C6H5NH3 plus is 2.4 into 10 power minus 5 molar. Okay, so for anilinium ion Ka value is given. We should calculate concentration of sodium hydroxide required for this anilinium ion to maintain the concentration 1 into 10 power minus 8 molar. Say this is the reaction in this aniline C6H5 NH2 plus H2O gives rise to C6H5NH3 anilinium ion plus OH minus. Here aniline is a base, that means it can accept a proton from water. That's why we can get anilinium ion. So ionization constant of base, since it is a organic compound, it is a weak base. For this Kb, ionization constant of base Kb equal to concentration of the products divided by concentration of the reactant. Let it be equation 1. Kb for C6H5NH2. Aniline is also a weak base. For this Kb expression we can write like this: Kw divided by Ka for C6H5NH3 plus. That means Ka, ionization constant of the acid for anilinium ion. Here anilinium ion can donate proton, that's why it is considered as weak acid. For this Ka value we can consider. So in the question Ka value for anilinium ion is given, that is this one. So Kb for aniline equal to Kw, we know that 1 into 10 power minus 14 divided by, substitute the given value, let it be equation 2. Now the dissociation of aniline occurs in presence of NaOH, and this dissociation decreases due to common ion effect. Okay, so because of the common ion effect, the dissociation of aniline decreases. See this reaction: when aniline is added to the water, it is changed to anilinium ion and produces OH minus. Now to this mixed solution we are adding NaOH. Already we know that NaOH is a strong base. Strong base means it undergoes complete ionization and produces OH minus. In this reaction OH minus are there. Again here OH minus are produced. So OH minus ion is the common ion. Due to the more quantity of this OH minus ion, the dissociation, this reaction, the dissociation of aniline is decreased. So that is nothing but common ion effect. So given aniline concentration is this one, anilinium ion concentration this one. From equation 1 and 2 we can write this one. Equalize these two. Left side Kb, right side terms if we equalize, then this term is equal to this one, anilinium ion concentration, this one 10 power minus 8 into OH minus ion concentration divided by aniline concentration. From this OH minus ion concentration we find out. So NaOH concentration is 0.01 molar. Okay, so what is the option? Option B is the answer. See the next question, next to topic. Salt hydrolysis. Before going to salt hydrolysis, you should know the difference and also meaning between hydration and hydrolysis. Both are known terms. These are not new terms. Hydration, hydrated salts are there. CuSO4 5H2O, blue vitriol, washing soda, complete formula. Already we know that Na2CO3 10H2O. That means in this type of salts some quantity of water molecules are also present. Those type of compounds are called hydrated salts. See the definition of hydration. The addition of water to a chemical compound is called hydration. Simply some water molecules are added to a chemical substance, that is called hydration. In this, no new substance is formed, just water molecules are added to the given compound. In case of blue vitriol, CuSO4 5H2O, 5 water molecules are attached to 1 CuSO4 molecule. In washing soda, 10 water molecules, Na2CO3 10H2O, 10 water molecules are attached to Na2CO3, 1 molecule. So in this way, some quantity of water molecules are added to chemical compound, that is called hydration. Remember, in this no new substance is formed. Come to the hydrolysis, a chemical reaction in which a compound reacts with water to produce other compounds. Here, a compound is added to the water, then chemical reaction takes place and forms a new substance. This type of reaction is called hydrolysis. Hydrolysis means by reacting with water, a substance forms new substances. That process is hydrolysis. Hydration means simply addition of water molecules to the given chemical compound. Now see the hydrolysis of salts. When we add salt to the water, hydrolysis takes place. Salt means it is a neutral substance obtained by the reaction of acid and base. These acids and bases are different types. Different types means strong acids, weak acids, strong bases, weak bases. So between these 4 types, different combinations are possible to get different types of salts. So now see the hydrolysis of these salts. When we add these different types of salts to the water, how hydrolysis takes place, what is the pH of the resulting solution, each and everything we have to learn in this topic. See this, salt hydrolysis. Salt means it has cation, positively charged ion, anion, negatively charged ion. The cation or anion or both of a salt can react with water to produce other substances is called salt hydrolysis. If we add salt to the water, then cation of the salt reacts with water or anion of the salt reacts with water, or both cation anion can react with water to produce other substance. That process is called salt hydrolysis. Salts are obtained by the following combinations. See the first one. Salt of strong acid and strong base. Strong acid HCl, strong base NaOH. HCl plus NaOH gives rise to NaCl plus H2O. NaCl is a salt. It is obtained by the combination of strong acid and strong base. In the same manner, K2SO4 also obtained from strong acid and strong base. In this, what are the acid and bases involved is KOH reacts with H2SO4, strong base, strong acid, and forms salt and water. And NaNO3, it is obtained by HNO3 and NaOH. HNO3, nitric acid, it is a strong acid. NaOH, it is a strong base. So these type of salts obtained by the combination of strong acid and strong base. Now take the example of K2SO4. This K2SO4 is added to the water. Then what happens? It can release K plus potassium ion, SO4 2 minus sulfate ion. Inside the water, H plus OH minus ions are there. This K plus cation combines with OH minus to form KOH. H plus combines with SO4 to form H2SO4. KOH, H2SO4. These are strong substances. This is strong acid, this is strong base. Again, these compounds undergo ionization and produces K plus OH minus. Here H plus SO4 2 minus. That means when salt obtained from strong acid and strong base is added to the water, it undergo ionization. The nature of resulting solution is neutral. Equal number of H plus and OH minus ions are present when this type of salt is added to the water. So in simple sentence we can say there is no hydrolysis of salt in case of strong acid and strong base. Okay, so the nature of the resulting solution of aqueous K2SO4 is neutral and pH is 7. Okay, see the next combination, salt of strong acid plus weak base. Salt obtained from strong acid like HCl, weak base, NH4OH. HCl plus NH4OH gives rise to NH4Cl plus H2O. So this is an example. Another one, NH4NO3. In this, acid is HNO3. Strong acid, base NH4OH. Weak base gives rise to NH4NO3, ammonium nitrate plus water. CuSO4 also obtained from strong acid, H2SO4, weak base, CuOH twice. FeCl3 obtained from strong acid, HCl, weak base, FeOH thrice. ZnCl2 obtained from strong acid, HCl and weak base, ZnOH twice. In this way, these are examples for strong acid and weak base salts. Next, see one example, ammonium nitrate. This is ammonium nitrate formation. When this salt is added to the water, it produces NH4OH plus HNO3 because in this cation is NH4 plus, anion NO3 minus. Here H plus OH minus. NH4 plus OH minus combines with each other and forms weak base NH4OH. NO3 minus H plus combines with each other and forms HNO3. Here the formed substances, see their nature. It is weak base, it is a strong acid. Weak base means its degree of ionization is less. Strong acid, HNO3, it is a strong acid, that's why it can ionize completely and produces H plus ions. So in the resulting solution of, in the aqueous solution of ammonium nitrate, more number of H plus ions are there. The concentration of H plus ions is greater than OH minus ion. Then what about pH? Less than 7. So we can conclude from this, the aqueous solution of salt of strong acid and weak base is acidic in nature. pH less than 7. Now see the next combination. Salt of weak acid and strong base. Example, ammonium acetate. Formula CH3COO Na potassium cyanide KCN. Here CH3COO Na. Weak acid CH3COOH reacts with a strong base NaOH. Then we can get CH3COO Na plus H2O. Now this salt is added to the water. We can get CH3COOH plus NaOH. It is a weak acid. It is a strong base. So weak acid means degree of ionization is very less. Strong base, it can ionize completely and produces OH minus ion concentration. OH minus ions. So the aqueous solution of CH3COO Na having more quantity of OH minus ion. That means OH minus ion concentration greater than H plus ion concentration. So pH greater than 7. The nature of the resulting solution is basic nature. Okay. We will meet in the next class.